started, so we'll kick it off. Let's welcome to the new community conversations hosted by the Autodesk community. Our community conversations are new live virtual events designed to allow you to gain expertise, connect with leaders, and grow your community network. So go ahead to the next slide. My name is Kimberly Fuhrman, and I'll be your community host. We are joined by the very talented Donnia Tabor-Hanson. She's an Autodesk Revit certified professional, and some of you probably know her as CAD Mama. Today, we will be discussing family, this isn't right, is it? Revit family types and templates? That's what's in my notes.
No, this is
no.
We're building muscles.
We're building muscles on our Revit families, so we'll go from there. We didn't update. All right, so Donnia, you want to introduce yourself? Tell us a little bit about yourself.
Okay. My name is Donnia Tabor-Hanson. I live in Knoxville, Tennessee, God's country. And I have been doing Revit for, I don't know how many years. I started in AutoCAD 1.2 and just sort of evolved into all of this. And I thoroughly enjoy what I do. And I love sharing it. This is fun.
Awesome. Thank you, Donnia. And I'm so excited to be hosting with you. You can go ahead to the next slide. All right, so some ground rules and norms before we begin today's conversation. Everyone's line is muted to reduce background noise because we are recording. We do invite you to keep your camera turned on if you're comfortable, so we can get as close to a physical environment as we can in our new virtual world. The conversation is going to be exactly that. If you have a question, go ahead and use the Zoom raise hand function, and our moderator will unmute you. Donnia will also be taking questions throughout. You can use the chat window at any time to ask a question, and we'll be keeping an eye on that for her. The session, as I said, is being recorded, and it will be emailed out to everyone who registered and uploaded to the community conversations site. Okay, go ahead and next slide. And I'm not going to read this entire slide to you, but just quickly our safe harbor statement. If we make any forward-looking statements, I don't want you to make any purchasing decisions based on those statements. If you are making purchasing decisions, look at the software in its state today and that alone. Additionally, Donnia Tabor-Hanson is joining us as a customer expert and independent of Autodesk. All activities, advice, and opinions shared by Donnia should not be linked to Autodesk. And now I'll turn it over. Oh, we have another slide. So I missed, yeah, my notes are all out of whack. But we do have our community conversations. They are hosted by our community managers, of which I am one. And this is an opportunity, as we said, for our customers, expert speakers, whether they could be employees, but we like to have our customers like Donnia, partners, or students actually present for our sessions. Our knowledge sharing, we get to ask questions and have an open conversation with each other and make new connections through these sessions. So go ahead, Donnia, and we'll let her get started.
All right, welcome to the third topic on Revit families in our community conversations. I have been using Revit for a long time, and the big thing I keep going back to, no matter where I've worked and what field I've been in, is the families. I like to make the families work for the projects, and I like to get into how to make them and how to get them to do what I want them to do. So let's just get right into it. Here's our meetup flow for today. We're going to do a quick review of the template, which we started out with our first session, how to create your own family template, which is very important. We talked about reference planes. It's our building bones in the last session. And we also talked about our shared parameters and family parameters. That's our ligaments and stuff. So now we're going to build muscles onto these families. And we're also going to talk about watching your weight because, well, in the pandemic, oh, that's something else. No, we're going to talk about watching your weight of your families and how you can get that done. And then I want to introduce you to a little bit about my parts department, which is where I keep pieces and parts that I use a lot. And it's something you want to start looking at when you're building your families and getting yourself going. So let's get into a quick review of the template. In the template, the one thing you want to do when you start a family, you want to choose the correct template for the family type. And when you create your own template, you start with a template that you're going to be working with most of the time, and you want to set it up for success so that you don't have to keep repeating things all the time. Check your project units. Put some minimal dimensions on your families, for your typical families, and on named reference planes. When I mean minimal dimensions, I'm talking about width, depth, height. Maybe I wouldn't get into much more unless it's a certain family type that has certain things in it all the time. I do want you to start looking at your object styles. If you have any object styles or materials, go ahead and put these in here. That way, you don't have to recreate that material every time you go in to create a family. And that way, you also have consistency with your family materials names, so you don't have chrome in there with an uppercase, a camel case, all lowercase or whatever. And that way, these things will start bulking up your projects. So by having these built into your templates, you already have them set and you don't have that problem. Now, I do also recommend that you get a family that has your basic materials and object styles in them, which I do this all the time. I've got one so that I don't have to do it in all of, I can just transfer project standards into the project that I want. I can also, in your templates, you want to add your shared parameters for any tags and schedules. And it may depend on the type of template that you're making. I've got about 8 different templates. One if I'm doing electrical, one if I'm doing gas, one if I'm doing a project, a family that has water in it, hot, cold water, filtered water, whatever. Now, so that's a quick review of templates and things you want to go. Most of those things you're going to find are going to be on your Manage tab or else in your Family Types dialog box from the first page of your Revit families. Now, reference planes. These are your bones. And they're important when you're building the muscles on here. So let's talk about the idea of you draw them counterclockwise around the centroid. And if you don't understand this completely, I'm just doing a review. This was last month's session. You can go back and review that from the community conversations area. So you draw counterclockwise. This keeps the front of the reference plane to the inside and the back of the reference plane to the outside. There's a positive and negative side. The exception would be if you're going to have an object of extrusion be in the same quadrant. And I tell you what, we're going to look at that today, how I would draw one reference plane one different way. We'll look at that. In elevation views, all reference planes have a positive moving up and a negative going down. So when I'm talking about the centroid, to draw on the centroid, I'm talking about in plan view or in an elevation. You can do your side view, the side reference planes up and down, up on the right and down on the left. This keeps the positive negatives where you need them to be. And this is going to come into play today when we start building these muscles. You're going to see some of these. And name each reference planes. Always name your reference planes. And keep the reference planes within the area there's things being attached to them. You don't want all the reference planes going, you open these families and they got all the reference planes horizontal and all the reference planes vertical and they go all over the place. And you're like, I can't figure this out. Keep them, bring them into the areas that they're being used in. They don't need to go all over the place. And if your company is using subcategories, you may want to look into that. I'm beginning to introduce subcategories for whether it's a weak reference or whether it's not reference. And then I just introduced 2 subcategories and you'll see those today. And shared parameters versus family parameters, something that also matters when you start building muscles and stuff. Shared parameters, you need to add these into your templates too, as far as anything that would go into tags and schedules. And we're going to be linking to some of these parameters and stuff today. But before you go editing your shared parameters, check with your BIM manager, your VDC, before adding any of these. They may have it locked down. I don't blame them, ours is. It's a read-only. So to keep people with a chance to have some flexibility, my team created an XYZ parameters. XYZ is the category, so it shows up at the bottom of the list. And in there, there's going to be some different parameters, like there's 10 text parameters, text 1, text 2, through 10, length, integer, anything that I could come up with. We added 10 more parameters so that it gives them flexibility to add parameters for like maybe a custom customer that you do a chain customer that you do and you repeat these things over and over. They request certain things in their schedules. Family parameters are great for dimensional parameters most of the time. You don't have to use shared parameters, but some dimensions parameters may need to be scheduled. Those would have to be shared parameters. And that's if you're doing something with maybe a some sort of width or length that you're working with. If you're working on columns or beams or ductwork, you may have to schedule your links. I work in kitchens. I don't schedule a lot of links. Labels is something, I think I may have mentioned labels before as being something you had to have a shared parameter. It can be a family parameter. I used a family parameter last week. Someone wanted a label on a table that gave its width and its depth, so that when they put the table in the plan view, they could see what width and depth it was. And they also wanted the same thing for shelving. I'm gonna put that on my tips. I need a tips and tricks day. Yeah, that's gonna be one of my tips and tricks day, how to do that. Okay. Building the muscle. Now, let's do note here that some of this stuff that we're going to go through today is going to be extremely basic. Things that you should have been doing by now. If you've drawn any families at all, you have seen some of these basics. I hope to throw in a couple of little golden nuggets just to save you a little time and make things easier for you in your future. But this could not be a series on Revit family building without going through these things today. So hang in there today. And by the end of the day, my little nugget at the end is going to be my parts department. So I want to get through some of this stuff to make sure we have time to get in the parts department. Okay, when you build muscles, let's start talking about the basics that most all of them use. They use a mode and a draw. You've got your X that says, forget it, I'm out of here. And then you got your check mark that says, okay, we're finished with this. You have your draw tools, you have your open and closed. Once you're closed are your ellipse, rectangle, polygons, and circles. And don't forget to stop at the bar as you come out of your ribbons. Stopping at the bar is always fun. We haven't done it in a year, the pandemics, but this is a different bar. This is your options bar. So stop at the bar and see what you can do there. If you're not using a closed profile, then it will have you set and change for most of the things that you're working on, because you do have to close profiles a lot in your extrusions and sweeps, etc. And also don't forget to stop at the properties dialog box, because there's some things you can preset there so that you don't have to go back later and do, such as your heights, your ending heights, your materials and things. You can preset these things as you're building your family muscles. Okay, so we're going to start with an extrusion, which is nothing more than a 3D extrusion longitude from a 2D profile. It will go perpendicular to the plane that it is given in. It does go in one direction. It does use the mode and draw tools. You do need to check, stop at the bar. Y'all are going to love that for the days out. Stop at the bar and get yourself set up there of anything you need. Don't forget to set your properties. Now, with an extrusion, one of the tricks to that is you can use multiple profiles in extrusions, as long as the profiles do not cross each other. They can be concentric or inside of one another. So you could set up one closed profile inside another to keep you from having to go back and putting a void in later, so that you can have it like that. So with that, let's get over to our favorite place. Let's go to Revit. Now, let me just give you the lay of the land. I'm working off of a table template that I have. I have a reference plane here, and this reference plane is not referenced. It is a pink. It's one I use in my object styles. I have not referenced and weak reference. That's the only two I have. Remember that anything you put in your object styles, anything you put in your materials, those all go into your projects. So you want to be consistent. That's why it's nice to have it in a template. I have a back front. This is the plan view, and you can see if I go to a front view, here I have my legs. I don't need to take my legs all the way through, so I bring it down in that area. In the right side, I've got a backsplash area, and you see I can just, you can pull these up as you need to around there. So it kind of looks like a table. So that's what we're starting with. So that's what I mean about your templates and getting, that's just a slight review about templates again. Let's go to extrusions. First muscle we're going to build is the extrusion. And I'm going to go up here, and let's say I want to build some table legs. I can do all the table legs at once. I want some round table legs. It's 12 inches. Well, I don't want that. I've already got some parameters built into this family, such as the leg height. This is a table template, so I've got things built in that I would use in all my tables. So I'm going to go ahead and tell the height that I want it to go to the leg height. There, yes. And I want to do circles, so I come down here. As long as I get where I can get it on the intersection, that is actually locking it to that intersection. with a circle as long as you get the center on there. But let's say you have a circle that's slightly off and you've got a lot of, I wanted that at one, and you've got a lot of reference planes in the area. Here's a little trick for you. Here's your first golden nugget. If you haven't found it, you can turn on the center line of a circle, and then you can use that to align to reference planes if it was not on there. So if you're not sure if the circle is on there, or if you flexed your family in a circle extrusion didn't move, you can go into that family and just go edit and just turn on its center point so that you can see that and use your align tool to align it down there. Now take that off and I hit enter. I've got legs. Let's go look at the front. Yep, that doesn't look right. And yes, I did this on purpose because I wanted to bring home a fact that I did not go through the entire properties when I went through there. One of the things I should have caught was the reference plane was set to top. Why did I tell you to name your reference planes? Name all your reference planes. People don't notice sometimes the reference plane that comes at the bottom of a template doesn't have a name. When I taught about reference planes and stuff, I went in and told you, why don't you go ahead and name it? So name it base. Well, I can edit the work plane, not top, base. Get your little self down there. Boom. Now it's where it's supposed to be. Its height's where it's supposed to be. I didn't stop at materials either. Well, I'm doing a table. I'm in the kitchen. I'm going to just give it a material. Everything's going to be stainless steel. So if I just call it material, then I can just assign it material, and then I can go into my family types dialog box, and now I have materials in here. And I can go get, look at that. None of my materials have anything going with them. I'm doing this on purpose because next month, guess what we're talking about? Putting some skin in the game. We're going to talk about your materials and how to get these changed. This is what happens when you bring up a template from an older version, and I'm in 2021. So we'll deal with the materials next time. I'm just going to call this stainless steel brush. It still looks like what I need to, but now it's like, you really ought to update those. I mean, if I go into a 3D view, I can see, yeah, look, it's got more of a look of a stainless steel. So that was just to show you that, you know, we can do some of these things. This could have been done on the way down through if I had done that before, and we'll look at that again. So extrusion's pretty easy. You should have done it by now. Oh, by the way, when I am in here, let's go to the front view. I can't, if I grab the top of this, want to move it, it gives me an error because I'm connected to something. I told it to go to the leg height. So without changing the leg height, I'm not going to change that. I don't have to have a reference plane because I gave it that. The reason it doesn't have a reference plane is my leg height is based off of a formula. The formula is the counter height minus the top's thickness. Those are given in my dimensional areas. So there's my top thickness, my counter height. So there's your another little nugget. You don't have to have a reference plane for everything. If you've got formulas to deal with something like that, it can use like that. It's not typical for me not to have a reference plane, but that was just something I could throw in. All right, so that's an extrusion. Are there any questions coming in? No? We're riding along, yay. Okay, the next thing we're gonna go to is a blend. The difference between a blend and an extrusion is you have two different profiles. It comes from two profiles instead of one. It does go in extrudes in one direction, perpendicular to the plane it was defined on. It does use the mode draw. So now we have two modes. It defaults to edit base. So you don't hit edit top until you're through editing the base. You do have to get to stop at the bar, and you're set to chain unless you choose a closed profile. I'll be using a closed profile just for example here. And you do want to review your properties on your way down. And you cannot use more than one profile for bottom or top. That's its limitation. Where an extrusion will let you use more than one profile, it will let you use one profile for bottom, one profile for top, and it's just going to go in the direction. Then you can tell it height and attach it to reference planes or something if you need to. So let's get over and do our create blend. So just by going over the rules, I'm hoping you're picking up on why these things work the way they do and how they work. And I'm going to, first thing I want to do is I'm still set for the top. I'm going to set my profile or set my reference plane for base so that I'm working on the bottom. I'm setting for the bottom, so I'm going to go ahead and pick on this. 12, no. Let's go ahead and again, I'll just take it to leg height. Gives me a nice length to work with. It's set for base. I can tell it to go to the material, and I don't have to mess with that anymore. You see it automatically went to my stainless steel brush. So by doing these presets, you are moving along faster than if you have to go back and do these 3 steps later. And then once I'm done, I can hit, if I do anything else, let's just show you, if I do anything else, and then I say edit top, I get this error message down here because more than one loop was done. So continue. That means I need to go in here and delete that. I need to go to edit top, and then I can go get me, let's do it the other way. I like this because it's kind of neat. Whop. When I go into this view, I can see that I've got my twisted little set there going to the front. You can see it went up basically about the same height as the other. So it's a matter of presetting some things, made it easier to get this done one time. I didn't have to go in here and pull it to the reference planes. I already had it set. I didn't have to pick it, change the materials. I already had it set. All right. Let me back to here. I always want to go back to the beginning. And the next we're going to work on is a revolve. Revolve will revolve a 3D solid around a 2D boundary line, or created from a 2D boundary line, and revolve around an axis. Revolve gets its shape from having a closed boundary line, and it does use the mode and the draw tools. It will set you for chain if you're not, the chain is automatically checked if you're using an open boundary line. And you do want to review your properties on the way down and verify your settings. You do have some different settings. You have start and end angles, and we will look at those. You can use more than one profile, but only one axis. And the profile can never cross the axis. It has to be to one side of the axis. So let's do a revolve. And the first thing you want to do is you want to make sure that you're set in the view you want to create it in. If I'm going to make a bowl sink in this table. So I want to go to the front view because that's where I will see the curve of the bowl, the profile of the bowl. So I'm going to go in and hit create and go to revolve. And the first thing I like to do is I like to set my axis line. And well, you're going to be right down the middle. And then I can go to my boundary lines. And I'm going to do something simple with an arcing bowl circle here. Go out, bring it down. Maybe I want to do an offset, 1/8 inch to get that even in there. I want to close the lines off. Stop at the bar. Stop at the bar. It's still offset to 8. If I drew this, it would set it up at 1/8 of an inch. So if I stop here and set it to 0, then I'm back on to where I'm drawing. Otherwise, it would have drawn an offset 1/8 of an inch away. And I want to close it down here. And then I want to check over here if I got everything I need. Playing back. I'm going to leave that for right now just to show you how I do. Then I can go get material. Nope, I don't want that material. I want equal material. You're just going to be material, so it's automatically assigning it. And when I finish my revolve, I'm going to go to a 3D view. I got a bowl. I got a nice bowl. It's a pretty bowl. When I go to the right side, I see it's on the back. Again, I want to emphasize named reference planes because now I can say, no, you don't need to be on the back. You need to be on the center of the front right. Pops it right over there. Named reference planes. That's my motto of the day. So let's go back to the front view and play with this just a little bit. I said you could use more than one. Let me edit the revolve and let's go get anything out here. Let me do something fun. I don't know, just because I can. And when you get these done in this mode, yeah, that's unique. But let's play around with this over here. I told you we'd come back to this. Starting at 0 and ending at 360. What about ended at 270? Okay, let's look in plan view. This is your angle 0. This is your angle 270. Whoever did this did not look at a protractor that I grew up with, because 0 was, I don't know. It's civil people understand this. They didn't work with protractors either. So when you understand that, you can understand which way your angles are going. If you had an angle, you can also rotate this around if you need it to be aligned to a reference plane or something. You can do that too. But one of the things that we're working on in this class today is going through the nuances of everything that you can do in all these different muscles that we're building. So I wanted to make sure to show you that. So with that, that's our Revolve. That's one funny looking thing. I don't know. We're playing here. All right. I'm seeing no questions at this point, so we'll go on. The sweep is next. So with the sweep, it's got more stuff to do to it. So I'm going to go through a bunch of things, and then we're going to go play with them. The sweep is a 3D solid that moves along a 2D profile path. The first thing you're going to want to do is set your reference plane. Look, they even moved it up over here. It's going to start. It's going to start, man. Set your reference plane. They moved it over, it looks like, to the front. You want to make sure that you set your sweep, because when you set your reference plane, it's going to give you a plane perpendicular to that reference plane at the point that you start on, your first line of your outline, your path. It's going to set something perpendicular there. So you want to make sure you've got that set where you're going to want to play around at. So you want to set your reference plane first. As I love it, they put it up front. Then you get to decide if you want to select a path or pick a path or sketch a path. And we're gonna experiment with both today. I'm going to start with the sketch path later. The sketch path is where you draw it. Pick path, you need to have some 3D edges to pick along those paths. And like I said, we'll look at both. Sketch path remains on one single plane. Whatever plane you have picked and set, that's where it's going to stay. If it is a pick path, you can actually change planes depending on the surfaces and the edges that you're picking. Yeah, so it can change planes. It does use the mode in the draw. And it does have, stop at the bar. And if you're using a closed profile, the chain won't be there. You can use a closed profile for your path and make it, go all the way around something and close up. And you do want to review your properties. You don't have your start and stop, but you do have, your up and down, you just have to go whether it's visible, you can get your materials and stuff. And when you finish the path, you do have the green checkbox to go to. So you have to finish your path before you move on. And I'm going to come back to that. We're going to go through a couple more of the rules, and then we're going to go play with some of these. When you build a muscle, then once you set your path, you've got to determine what shape you're going to sweep around this. So you can select a profile to determine the shape, and you can do or by sketch. And if you do by sketch and then say edit profile, it's going to immediately go, let's put you in a view where you can look down perpendicular to your first vertex of your path. And that's going to show you where you've got your outline for where you're going to start your what is it? The centroid basically of your sketch for your profile. And if you do this on a curve, that's going to show up in the center of the curve. And you may end up having to do a 3D view to see some of this stuff. It will show, this is what I'm talking about. This centroid right there, that's the centroid of your profile that you're going to do, and it's based on the reference plane. So you can see that there would be a reference plane here. That just shows that's another reference plane that was in my family. The reference plane that's on it will be right here, and it's lined up right here. You can draw whatever you want, and that's where it's going to sweep around your path that you've created. It does use the draw tools. You must have a closed profile. You can have more than one profile for the same path. That's like I did with the Revolve. And you do have to finish the profile using the check mark, much as you finished your path. Finish your sweep, then when you're done, and then you can see your sweep. If you're going to do a select profile, you can select the profile to determine the shape. Then you can load the profile, and then you can pull down the profile by sketch and define your profile from the drop down. Change it to, it won't prompt you to change to a view, but you may want to change to a view to see which way it's going, because you want to be one that's perpendicular to the first vertex so that you can see your profile, make sure that it's looking right. You do have different things on the options bar. You now have a flip that you can flip it if need be. You can change it on, move it on the X and the Y if need be. Then you finish your sweep using the checkbox. Now, which way the path is drawn matters. There will be a test. There will be a test later. We'll do a test later. So let me just go on back. We'll leave it right here, and let's go do a sweep with a profile. I'm going to do a backsplash with a profile. So first thing you do, you go get create sweep. I'm going to choose to go with a sketch path. I'm going to choose to go with what? Set my reference plane. Yes. Then I'm going to go to sketch path. They put it up there up front because I had to have it there. Yeah. Then I'm going to go with sketch path. And I'm going to draw a sketch path from here to here. Now, there was a question last month about how do I get my sweeps to stay where they're supposed to? Well, you can align things you should do when you're making families. You can also align the endpoints of a line. If you're not sure you got on there, I mean, it probably will stay, but probably will, and making sure is two different things. So you can align an endpoint when you're in any of these sketch modes, whether it's a path or profile. You can align those endpoints of lines to attach to something. Make sure that if you flex that width, that it's going to go with. Okay, so I've finished. I'm just going to have one line over this. So I'm going to go by a profile. I'm going to load a profile. Let me take it to where I've my muscle directory. I've got a profile for a backsplash here. Let's take note of which way the backsplash is drawn. You can see that it's drawn over to the right side of the profile family that it was created from. There is Revit provides you with a profile template. So profile is a profile. It could be used in a lot of different families and stuff. But I've got the profile and it's drawn to that side. That's important to know. And I'm going to tell it to go in there. And then I have to come up here and tell it to go to that profile. And then it looks like I could finish, but I want to go over here to the right view because that's the view that's perpendicular to what I'm drawing. And there I see my profile, but it's going to the right, but I want it to go to the left. So here's where I can use the flip. And I can come over here and finish that. Didn't hit all my properties again, so go ahead and assign that material while I'm still in here. Well, I still got it here. And I've got a profile. It's taller though. So let's look at this. If a profile is created properly, here's one of your little nuggets. I can go get the profile and say, get its type property. It has a backsplash height. Well, let's make that equal to, I don't know, my backsplash height, VS height, and my thickness to VS thickness. And that way, boom, drop its little head down there where it needs to be. And then if I go into my family and change that, let's make it dramatic. Let's go 8. You see my profile will automatically adjust with it. My question will be about the cost of over-constraining families with respect to performance of targets to yield. You only need to constrain things in one view. That's the biggest problem a lot of people have, is over-constraining that way. But I do like to have the constraints down, locking down the endpoints. I just noticed that question on there.
There's another question, Donnia, about can you go over nested families? Will you have time in this session to do that? Or is that
when I get to my parts department, I'm going to nest a family.
Okay.
That's what the parts department's there for. I've got little things I can just like put in there. Yes.
There you go. All right,
yes.
Cameron, hang tight.
Okay.
I have a question for you too, just from my experience from building
yes.
families. How do you determine whether to use an extrusion or a sweep. What is your criteria?
You're right. This one, because it's in a singular line, it doesn't matter. I just have a tendency to put sweeps around tables because I'm about to show you a sweep around the front of the table. And it's just a habit of mine. Neither one of them have to do with much weight. And we are going to look at the weight and how things make weight and what things make less weight than others. I've got a whole session that we're going to look at the weight of the families and how they do. But in this case, sweep, or because I was going to use a profile, I have a tendency to go with a sweep.
Okay.
And as opposed to extrusion. If that, if this family had needed a rectangular shaped backsplash, I would have gone with an extrusion. Mm-hmm. But because I needed this shape, I went with profile. Does that help out?
Absolutely. Michael asks, I'd love to hear about reporting parameters and how those might be used.
We're going to have to cover in another time. I'm making a note. I've got a whole post-it note things up here. Things I want to cover in the future. Reporting parameters.
There you go, Michael. So you can look for a future session from Donnia on reporting parameters.
Oh, honey, I've got about 15 post-it notes just lined up here.
Awesome.
Lots of things, grouping and nesting and all kinds of things. Okay, so let's look at something else about the suite. Now, okay, at this point, here's the test. Everybody raise your dominant hand. I'm right-handed. Everybody raise your dominant hand and draw a line. Just draw a horizontal line. And can you tell me which way you drew the line? Was it left to right or right to left? Hold that thought. Here's the reason why. You saw me draw this line. When I did this sweep, I drew it from left to right. Most people that are right-handed, we read from left to right, we draw from left to right most of the time. I'm going to do another sweep, the exact same thing, but I'm going to do it on the front of this table. I'm already set to top. I'm going to go back with the sketch pad. I'm going to draw it from right to left. I'm not going to bother with locking it down and stuff. We got a lot of things to cover. I'm also going to choose the profile, and I'm going to switch into my right view to see it came up on the other side. Before I had to flip it. So your lines, when you draw them, have a front and a back, just like the reference planes. So it matters which way you draw a line as to which way you're going to get your profiles and stuff. This one had to be flipped to get it in that direction. This one stay here. Also notice that this profile came in the exact same height as that one because I had set it as a type parameter. So if I change this to 5 again, put it back down real short, notice how they both went down. Because I did it by linking a type properties from a family that was nested in here. I linked the type properties to a property in the family. So when adjusted all of them. There's your other little there's another gold nugget. All right, let's do a sweep that you draw the profile now. The sweep with a sketch. You're going to go to the view that shows the path at the reference plane. You're going to use the draw tools. You must have a closed profile. You can't have more than one closed profile. And when you're done, you're going to finish the profile, and then you're going to finish the sweep. So now I'm going to put something around the front of the table. Sweep. And I am still set on top, sketch path. And I'm going to just draw it around. And I am not locking things down to reference planes. That's not what I want to be. I'm in the wrong place. Let's go back, cancel this. I knew when I went in there, it was wrong. Okay. Yes, just stop. It took me to the place where it wants to pick some things. Let's go back to sweep. Sketch path, everything was already set. Yeah, I wasn't getting pink lines. I need the pink lines. And yes, I'm not locking things down. I normally would, but for the sake of this today, we're done with that. Now I want to go to sketch path, and it's wait a minute, not sketch path. I want to do profile, edit profile, and it's going to want to take me into a view perpendicular to the first line that I drew. Now here is where I want to, if I want to draw something that's going to be around the edge of this table, I know that I didn't have a reference plane for the top thickness. I can create a reference plane here so that this profile that's going to go around, I want to make sure that I get my measurement from the reference plane, not from the reference plane inside this sweep. I want to make sure I get it from the reference plane to the reference plane I drew. Can't help myself with this one. Give it some name. And then I can assign this inside of the sweep that I'm doing. I can, where are you going? Inside of the sweep, I can assign this to my top thickness so that it will always be inside of there. The reference plane is inside of here and the parameters inside of here, and it will still work. I don't have to have it. In other words, I don't have to have all the reference planes in the main part of the family. I can have it inside of here so that now when I'm still in my edit profile, so I can just start drawing. Maybe I want to have a marine edge come up. I don't know what I'm doing. I just want to have an edge come up and go around the edge there. Always make sure it comes to there, and let me go back and get another line. It was chaining on me because it wanted to close profile, so I hit escape to go out and get me another line. Then I can trim it up and finish profile and finish the sweep. And that would put me with a nice little marine edge. It would be the thickness. So if my thickness of my top changes, it will automatically change the thickness of my profile. So that is a nice little trick to do if you want to make sure that you're going to have something, if you're going to do something like a profile or something like that. You can add your parameters inside your, whatever you're drawing, whatever your muscle that you're building, you can put that in there as well. Okay. So that should cover sweeps. No, that doesn't cover sweeps. What did I tell you we would do? The sweep with the edge. So, oh, I got to create something. Give me a blend. Let's go with, set myself on the base. And I'm going to, it's in edit bottom, so I'm going to automatically go to something. Give me something and then edit the top. It's 34 inches. That's good. That's good. We'll just, I need something to work with there. And then I'm going to go make it just something different. And finish, go to a 3D view. This ought to be fun. Yeah. So when I go into I'll do it a sweep and I want to do it with an edge, I can go in and pick path. And it leaves me in the pick path edge. And I can pick this path. And notice it put me my plane for drawing my profile right there perpendicular to it. And then I can come down here and go over here and go over here. That's good for now. Let's just go ahead and do that. And then I want to edit my profile. Let me just do a little bead along this. So I come in here and get to the center of this and finish this and then finish the sweep, finish my profile, finish the sweep. So that's how you can put something on an edge. And this would take it on around wherever I went. So that's how you can get a sweep to go, and it's not on a singular plane, but it's on the edges along things that you can pick. And you can edit this, not you, let's edit this. I can edit this sweep and I edit my pick path. If I take this one off and this one off, and then maybe go back and pick path and go to this one, and then finish the sweep. You know, no, we don't care about this project. You see, I got nice little moderate corners on it and stuff. But that's how you use a sweep when you want to pick edge. And it's the same with a sweep blend. So I can get away without doing that one also. But next we're going to do a sweep blend. Okay, so that's how you pick things when you want to do a sweep with the pick edge. Now, let's talk about the sweep blend. It took the blend and the sweep and melded them together, sort of, with a few limitations. The sweep blend has two 2D profiles. It goes from one profile to the other, but where the blend had a top and a bottom, which is kind of limiting if you think about it, because not all my blends go top to bottom, they go left to right. But anyway, it extrudes in one direction and only on one vertex. So it wants to extrude perpendicular to the plane that you started on, unless you're doing the pick edge. So the pick path. So now you can sketch your path, or you can go with the pick path and finish your vertex. Then it prompts you to select profile 1 or profile 2. And this is determined by sketch, or you could edit profile and load profile. I'm not going to go that far into that today because it works the same as it did with the sweep. Profile 1 will be at the start of your vertex. Profile 2 will be at the end of your vertex of what you have chosen as your path. It will prompt you to change views to go look at the perpendicular to your profile. It does use the mode and draw tools, and it does set you up for chain. Stop at the bar and you're going to see that you're chaining unless you're using a closed object. And you will want to review your properties to see what you've got, to verify your settings. And you complete your other profiles, and then you finish your sweep blend using the green check mark. So with that, let's go do a sweep blend.
While you're switching, Donnia, we're at the 10-minute mark, just to give you a heads up.
Okay. This one's going to be quick because I want to get into my, okay. Create, sweep blend. This is the last one too. Sketch path. Let's just because we can, let's do a crazy thing here. And I finished my curve. Profile 1, I might want to go to a 3D view for this. Anything. Profile 1, I'm going to go by edit profile. Give me a polygon of some sort. And I finished that. Profile 2, edit profile, go to a circle, just because it looks funky, and finish those. The only thing different in these and the others is you can use 2 different profiles. You can use the same profile if you want to, and otherwise it's a sweep. But the sweep blend is probably one of the least used, but it's fairly simple with that. So now we're at the 10-minute mark. Okay. Easy to tell you the rest of them. The voids, we're going to go through all the voids. No, we're not going to go through all the voids. They work exactly as their counterparts do. When you're building them, the rules are all the same. But the void must have a solid to cut. But a void can be the only thing in a family. But when you load it into a project, then you have to tell it to cut something. So you can cut things with voids in the family, or you can have a void that is a family that cuts something when it's put into a project. If you have a void that cuts something when it's placed in a project, it has to be a based family. I want to go through this real quick. I use a generic model family, face-based model family. I'm going to create an extrusion. I'm not going to care where it is. I'm going to go get a sink that has a void in it. Okay, I've got me something. And look, that makes me feel weird. Let's just go very thin. Yeah, we're good. I'm going to go and load a family. I'm on a nested family and no components are loaded. So let me go get my drop-in sink. Now the drop-in sink family, actually, let me open it. Yeah, there it is. The drop-in sink family was a face-based family. So the face that was in there was really thick. I made it a 32nd of an inch. I made it a minus 32nd of an inch. In this family, I have that. That will not show up when you place it in. That is the representative face that it will be cutting. I have an extrusion here that goes straight down. And then I have a, in here. I have a void extrusion that is cutting through this down here. If I go into, let's just load it in. Load into project. And I want to go to a 3D view because it looks better. Now give me that component and place it on face. It cuts through the surface that I had here, and it has my sink underneath there. So you can nest a void in. You put a void in and nest it into a face-based family so that it cuts something automatically. When I look at the front here, I see this family came straight down. When I look at the, no, not you. Let me go to here and go to the front view. Oh, it is down here. Wait, it's down here, way down here. I left on the floor. It's curved. This is where we want to start talking about real quickly. Watching your weight. First thing is model what you have to and detail what you can. I modeled that in a 3D. It came straight down. I use 2D line work to show up. I have the extrusion not showing up in front view so that I only have the detail lines showing up in there. I would have shown you that if I had more time. Let me compare these boxes right quick. I'm looking at the time. I don't like the time. Give me the box comparisons. Project I did. I have two boxes in here and their weight is entirely different. They look the same. That's the weight. That's the size of the file. They look the same here. They look the same in front view, elevation, right side elevation, 3D view. The biggest thing about these families is difference. And this family, the smaller one, if I say edit family, we have one extrusion. We are using model lines based on the correct reference plane to represent what it needs to. Model what you have to, detail what you can. The other box, and I have seen this a lot, edit family. And if I look at this family, there's an extrusion, but here's an extrusion. Let's go to the right view. Someone put a void inside the box. I see this a lot. If you are the manufacturer and they're building it off of your model, great. If not, why? Don't do this. So quickly, the last thing I want to do is show you my plates and cubes. I did an experiment on some families. I did just a cube, 504 is its size. I created a cube inside a cube, giving me the, just two rings, concentric rings. It went up 4. I added a bottom to it. It went up 4. I joined the bottom. It went up 4. I put one extrusion to create both holes. It went up 4. There's a pattern here. I added another extrusion. It went up 4. I made 6 extrusion. I'm up to here. But when I made the one void make all 6 cuts, then it became the same as if it was 6 voids. So the weight was the same. Now let me go to this other view of the plates. I called it a plate. It's just a rectangular plate. 404. All of these cuts were done with a single void with multiple squares. 436. 432, if I did multiple voids with one square, just copied it over and over and over. You see the same thing here with the holes. A single extrusion or void with holes all over. Now here's the funny thing. When I added, so here I added extrusions, and it's different from 436 with holes to 416 with added extrusions. But when I did it, that's with one singular extrusion, and this was with one, multiple, one that was just copied all over the place. So when you're talking about weight and what you're doing to your families, there's a lot of things you can do. And yeah, this is a great place to do a screen capture right there. There's your idea of what's going on. But there's a lot of things that you can do to help keep your weight down. And a lot of it is just paying attention to how much you're putting in your families. Model what you have to and detail what you can. I don't need screws and bolts. Parts department. Really quick, last thing. I'm going to go back to that table. Give me a new Oh no, do I have it open still? Cancel, cancel, cancel. I want to do this too quick. Here's my table. Okay. Okay, so the sink is one of my parts. But if I want to go and say load component, load family, I go back to my muscle. I have the parts department here. You can only imagine I use a lot of casters. I mean kitchens. But I also have, here's the legs. I'm not going to build these legs every time and every table I build. So I build these families in here. And then I have them where I can align them and lock them down. And lock them down. And if you build the families right, you can also link parameters. So I can say this family says it's got casters. Well, maybe I want to make casters an option. I put that in my constraints, which is where my team knows they always look for things they can play with. Maybe I don't need something on the front. Maybe they're going to slide something underneath it. I can take the brace off the front. I do have a set of legs that don't have casters. If I'm not going to use casters, why would I put casters options in there? So there's other things you can do to keep your weight down. In my family, in my parts department, I have a lot of things like switches and casters and all kinds of families that I can use. I'm gonna have to stop. There's more coming up, more things to do. So I want to give you hints of things that I want to get into, and some of these will be the nesting families and talking about that. And we'll talk about arrays and arrays with nested families and linking parameters. And right now I need to turn it back over to Kimberly so we compare the plates. Okay. I want to do the parts department real quick, as time permits. Okay. So that was a lot. Hopefully you got a few little nuggets in there. Keep things as lean as you can. There's some topics coming up. I know the favorite fabulous formulas for families in Revit is going to be a real hot topic. The next one is putting the skin, and there's where you can go. And Kimberly, yours is.
Yes, thank you. Donnia is always a marathon session, but man, I always get something, you know, even having used Revit for many, many years, always learn something new from you, Donnia. So thank you so much. If you're looking for other ways to connect and engage with our community, I believe Kate has put some links into our chat for you to check out. We also have our user groups, our forums, Twitter, and so much more. So feel free to check out those links. You can also follow us on Twitter at ADSK Community. So thank you all for attending our community conversation today, taking time out of your busy schedules. Continue to stay connected with us in the Autodesk community. We're looking forward to interacting with you there. And don't forget to RSVP for the upcoming Revit family community conversations with Donnia and other guests. So we did it, Donnia. We're there. Thank you.
That
all.
was so much fun.
Yes.
Thank you.
Absolutely. I hope everyone has a great day. Stay safe out there.
All right. Bye.
Bye-bye.